Hello everyone, welcome back to the another session in design and analysis of algorithms. Today we are going to discuss about optimal merge pattern. This topic you will find in third unit topic number 6. Now let's get started. This video will help you out to understand what is optimal merge pattern and how to solve this problem. That means we'll give solution through greedy method. We'll apply greedy method to find the solution for optimal merge pattern. And the third also we'll be going to see, which is two-way merge pattern. These are the three topics what we are going to cover in this video. If time permits us, we'll see one example problem from the previous question paper. Otherwise, we'll make other video to cover this example. Now, so what is optimal merge pattern? The name itself, it suggests us that we are going to do some merging operation. So merging can be done in many ways. When you have two files, now let us understand that I have A and B file. So the file basically consists of some several records. Let's assume that A file is having n number of records, B file is having m number of records. Now, when I wanted to merge these two files, the sorted file, the target file or the sorted file is what? Collection of n records plus m records. So this is what actually merging. Merging will do based upon the number of records what are available. We'll take some example to show you in better way. I'll take some example. Now assume that I have two sorted files, A and B. In this file, I have some records. Number of records are 3, number of records are 5, and 8, 9, 12, some 11, and 18, some 16. Now, so here, how the way merging operation will going to be performed is, when you consider these kind of files, when you have these kind of records and these are the files. So how the way you have to proceed is, you have to first of all compare the first two available records. Okay. Now this is 3 and 5. Whichever is the smaller one, that is going to be placed in the target file. So in between of 3 and 5, that smaller is what? 3. Okay. Now 3 is in target file. Now, so the left records are what? These are what? Left records. So now again comparison will be starts with that 5 and 8. We'll be going to compare these two. So when you compare these two, identify the smaller one and place in the target file. So that is what? 5. Now this time 8 and 9. So smaller is 8. Now the next is 9 and 12. Now it is 9. Now next is 12. Now next is 11. Next 12, 16, 18. So this is what the basic example. From this example, we understood something that when you have a records, or as far as the example is concerned, the number of records of this file is 4. The number of records in this file is 4. So the target file, if you see, it is 4 plus 4, which is 8. Now, let us assume, as you have here the same number of things, I'm not going to take same number. I'm just taking in formula wise that n records and m records. For sure, this will be big O of m plus n records. So this is your target file, right? Right. Now we'll see a common principle, how the way you have to do optimal merge pattern. When more than two sorted files are to be merged together, the merge can be accomplished by repeatedly merging sorted files in pairs. Thus, if files something x1, x2, x3, x4. So in the previous example, we were taken only two files and we shown how the sorting pattern will get accomplished. Now in this example, I am taking 4 different files and these are what sorted. So how the way I am going to proceed is, we will be going to find it out merging in between x1, x2, we'll get some target file which is y1. And this y1, whichever file I got, and x3 what is available, that the two are going to be perform merge operation. Okay. Now y2 and x4 we'll get some sorted file. the target file y3. So this is the way how you have to perform the merging operation. So here the way how you get y1 is after you merge these two, you'll get y1, right? Now I'll show you the example for the better understanding. So I'm taking just the values of x1, x2, x3, which are 30, 20, 10. So 30 are records. Don't assume that these are just numbers. No, these are not just numbers to see. These are what available records in the file. If one file is having 10 records, if other file is having 20 records, if I wanted to make into one file, which is C, now this I am calling as merging. Merging is nothing but what? A plus B. That means 10 plus 20 records will get available in C. So 10 and 20 are indicating the number of available records in this file. Now there are 30 records, 20 records and 10 records. How I can have merging operation? Now merge these two first of all, you'll get y1. Now y1 is what? 50. Merging means, see this example, you'll understand. 30 plus 20, which is 50. Now here 10 more records were left. So in merging I got 50 records together and here 10 were there. So I'm going to again merge as I wanted to see only a single file. Now 50 plus 10 becomes what? 60. So total 60 records I had in the target. So this target, how I have accomplished? By the moving from 50 plus 60. This is what the total cost of merging operation. The total cost of merging operation is 110. And do you have only this pattern to follow? No. You can also follow the other pattern. The other pattern is what? This is what example 1. That means pattern 1. And I'm taking the other example. See, the other example is what? I can also take 20 and 10 performing merge operation first. That means I have here 30, 20, 10. Instead of merging these two files, why don't I merge these two files? I can also have this. So 20 and 10 I'm going to merge. 20 plus 10 becomes 30. Okay. And after you got one single file, let's get one single file after you have all the merging operation. So 30 plus 30 again you will get 60. So what is the merging cost of this pattern? 30 plus 60 is equal to 90. Now look at these two figures. This is 110 and this is 90, which is lowest one, 90. So here it is also minimization problem. So greedy method is what? Greedy method is a technique where it can be applied either for maximization or for minimization. So optimal merge pattern is minimization problem. We will be going to apply greedy method on it. How I can apply greedy method? Greedy method says that you can apply it when you find the too small number of records, apply merge operation on it first. When you have a list of records, don't merge all at once or don't take randomly. The first priority is given to the lowest elements. So first you have to do lowest element, then you can do accordingly. So as far as this example is concerned, this will be the feasible solution. Correct? You can also have many more. As the number of records are getting increased, proportional to that, you will also get number of patterns to perform the merge operation. So here the feasible solution can be many things, but optimum solution is what? Doing the or performing the merging operation in between low elements, low number of record elements, then you will get the optimum solution. So the second merge pattern is faster than the first merge pattern. So you will be going to apply some greedy method on this problem and we'll be going to solve it by taking some example. Now let's understand what is greedy method. Though we know, we'll see in the perspective of optimal merge pattern. So a greedy attempt to obtain an optimal merge pattern is easy to formulate. Since merging an n record file and M record file, it requires possibly n plus m record moves. The process for a selection criteria is, as I said, at each step, merge the two smallest size files together. Merge the two smallest size files together. Okay, so this is what the first step before you apply the greedy method. Now let's see how we will move with the example. Now I'm going to take some simple example to give good understanding. x1, x2, x3, x4, x5 are sorting files, and the available records in each are 20, 30, 10, 5, 30. Now how the way you have to move as far as the greedy method is concerned. What is the selection? The process for a selection criteria is, at each step, merge the two smallest size files together. Out of all this, what are two smallest size files? X3 and X4. So you have to merge these two first of all. So I am just merging this one, 15. Now, so after this one, again you have to see which is the smaller one. So which is the smaller one? You will be having 20 and 15. Now it is what? 35. Okay. Now after this 30, 30 you have 60, and 60, 35 you have 95. Now the total cost of this tree is what? The total cost of this merge pattern is what? 15 plus 35 plus 60 plus 95, which is equal to 205. 205 is the cost of this optimal merge pattern using greedy method. Right. And we'll also discuss some of the example where we'll do merge pattern for the example. So take some number of files, something A, B, C, D. Assume that each have some record 6, 5, 2, 3. So here, how the way you have to proceed? You should proceed with the lower number of records. That means 2, 3 has to get finished first. Next, among these three, 6, 5, 5, which are lower one? 5 and 5. So these two has to be get merged. Next, 6 and 10 has to be get merged, 16. So finally the cost of this merge pattern is 31. So this is the way you have to calculate. That means big O of n plus m plus x plus y. So finally it is big O of 31, the cost of this merge pattern. So this is the way we have to calculate merging operation. And we'll see about two-way merge pattern also. So in two-way merge pattern, the name itself, it tells that it is two-way merge pattern. In the same way, you can also have three-way merge pattern. You can also have four-way merge pattern. That means performing merge operation in between two files is called as two-way merge pattern. Performing merging operation in between three files is three-way merge pattern. Likewise, n-way merge pattern. So now, let us understand what is two-way merge pattern. Now I am going to talk about two-way merge pattern. For this I am taking some example. So before it, we'll see the working principle of two-way merge pattern. So the two-way merge pattern can be represented by binary merge trees, as I specified this, that it is two-way merge pattern. Two-way merge pattern is represented by binary merge trees. So a binary merge tree representing the optimal merge pattern obtained for the above 5 files. 5 files are what? I'll point out: x1, x2, x3, x4, x5. These are what? 5 different files what I wanted to merge into single file. Now, so the nodes are called as external nodes. The remaining nodes are called as internal nodes. The nodes what I have specified with this rectangular boxes are called as external nodes. The leaf nodes are called as external nodes, and the remaining nodes are called as internal nodes. So each internal node has exactly 2 children, and it represents the file obtained by merging files represented by its two children. The number of each node is the length of the file represented by that node. So let us see, this 5 plus 10 is 15. Now 15 is the length of these two files, right? The merging of these two is 15. So the external node x4 is the distance of 3 from the root node to z4. The distance is what? The number of nodes in between this. That means from x4 to z4, how many nodes I have? 1, 2, 3. So the d value, the distance value from x4, it is 3. If you see from each, you will understand the same. So you have to calculate this distance from the node to level I at a distance of I minus 1 from the root. Hence, the records of this file x4 are moved 3 times, once to get z1, once again to get z2, once again to get z4. So this value of 5 is in for 3 times. That means 3 times into 5. And if di is the distance from the root to the external node for xi and qi, the length of xi is then the total number of record moves for this binary merge tree is diqi, where I is equal to 1 to n. The same thing is applied for all other external nodes. That means if you see the next node, which is the node x3. x3 also, how many, what is the distance of x3 from root node to your I minus 1 node? That means 1, 2, 3. So 3 into 10 plus. Next, from this node x1. So 20 is also having of 2 times. Now 2 into 20 plus. Now the next node 30. 30 is 2 times. 2 into 30 plus 2 into 30. Finally, you will get the answer, which is exactly equivalent to the cost of this. The cost of this is what? 5 plus 15 plus 35 plus 95. The cost what you will get over here, the cost will be exactly equivalent to this figure. Okay. So this is what your two-way merge pattern. Thank you all.